Hello everyone, welcome to Chem Skills YouTube channel. I'm here again with the same software CATIA but different module, that is DMU Kinematics. I'm here again after a very long time period, but this time I will continue many advanced modules like CATIA Kinematics, Solid Motion, ANSYS Fluent, Explicit Dynamics and many more other softwares. So let's move to the topic. Now the first one, we have the learning in this video. What we will learn in this video, we will have to learn the introduction part of the kinematics. Then what is kinematics, we will learn this one, and we will learn this one procedure required in CATIA kinematics. What are the procedure we have to require in the CATIA kinematics, we have to see this one. Then what are the basic terms and concept required in CATIA kinematics, we have to study this one. And after that we have to we have to see the highlights of the chapter 1. So let's move to the topic DMU kinematics. But before starting this one, I hope everyone know about that kinematics or mechanics. We can say mechanics also, because it is having the two parts, like the mechanical action and the second is the motion. Mechanical action we include forces, torque, loads. Of motion we have displacement, velocity and acceleration. So kinematics is very important terms in many industries, where we have many technologies like robots, automobiles, aircraft, satellite and many consumer electronic products which we are enjoying nowadays. Now we will move this one. What is CATIA kinematics? What is kinematics? Kinematics is a branch of physics that studies the motion of objects. DMU kinematics allow users to create simulation of assemblies. Now kinematics involve an assembly of parts that are connected together by a series of joints. All the parts are connected in the assembly with a series of joints, and these joints define how an assembly can perform motion. Kinematics does not involve any type of finite element analysis. Now this is a question. Question comes in our mind that can we perform any FEA part in CATIA kinematics? So we simply say that we can't perform any FEA part. Why? Because there are no associated loads or weights with the parts in kinematics. Okay, so this is the second line, that it deals with the motion of a mechanism without the consideration of loads or force. The second concept, we have the two concept. The first one is this one, that we can't perform any FEA part. The second concept is that we have to understand the degree of freedom. Everyone know about this one, that what is the degree of freedom. A free part is having a 6 degree of freedom. 6 degree freedom, just 3 is the translation and the 3 is the rotational about the translation. In order for an assembly to be used in kinematics, it must have at least 1 degree of freedom. Suppose we have one assembly in the CATIA software. Now we have to move the part with respect to each other. So if we fix all the degree of freedom of these parts, then we can't perform any motion or rotation of the part. So that's why it is saying that it must have at least 1 degree of freedom, and remaining degree of freedom are controlled with the commands. And the hardest part about kinematics is figuring out what joints need to be defined on an assembly in order for it to operate correctly. Also we can say that kinematics is used to check for clearance and interference among moving parts, and we also analyze the velocities of parts as well. Okay, we can generate and trace the surface volume of moving part also in the kinematics. See, we can find kinematics in almost every kind of industry domain, like we can say that robot industries, automobile industries, consumer goods industries, shipbuilding, aerospace industry, machinery industry. Where here we use this CATE kinematic software. Now we have the procedure for kinematic simulation. So what are the procedure? You can see this one. That first we have to create the part to be used for kinematic simulation using the modeling workbench. Okay, then we have to assemble the part, open the kinematics workbench and create joint. After assembling, we have to create the joint using in kinematics workbench. Now what we will do, we will fix the part which is not moving. Means we can say that simply the base part that is not moving, so we will fix this one, and then we define the mechanism and then simulate and analyze the mechanism. Now we have some basic concept in the DMU kinematics which are required. The first one is the axis system. So axis system, everyone know about this one, that we have the origin point, that is a fixed one, fixed origin point, and O, generally we say O. We have the x and y and z axis. X and y are horizontal axis and z is the vertical axis. The second one is the displacement. Displacement, it change from one position to another, and displacement is also a vector quantity. The third one is the rotation. Rotation about any axis. For the x-axis, if we say for the x-axis, the rotation angle is 0. Now linear velocity. Linear velocity is the rate of change of position. Then we have the instantaneous velocity, that is a rate of change of position vector, or we can say displacement with respect to time at a given time, and is equal to the first differential of position vector. Angular velocity. The angular velocity is a vector quantity that specifies the angular speed of an object and the axis about the which the object is rotating. We have acceleration. When an object's velocity changes, it accelerates. Suppose its velocity is increasing, then we can say generally that part is accelerating. And the next one is the degree of freedom, which we already discussed. The free part is having the 6 degree of freedom, and 3 translation and 3 rotation. So what is the highlights of this one? Chapter 1, that kinematics is a branch of physics that studies the motion of objects. Kinematics deals with forces causing motion and resulting in acceleration. Kinematics does not involve any type of FEA, as there are no associated loads or weights defined within the parts. CATIA DMU kinematic simulator workbench is used for kinematic simulation. So here we end the introduction part.